Okay, so today our topic is functions. So there are a lot of different types of functions. All of the expressions that we look at today will be functions. And so I'm just going to work through a few of these. These are very similar to things you've done in Algebra 2, so they're not incredibly difficult. So one of those things that we're going to do is just to evaluate functions. So if you have a function, something like that, and the direction is to evaluate. So let's look at f of 1 and f of root 2. So evaluate just means to plug those values in for x. So you just replace x with whatever numbers. So we'll do f of 1 first. So always put parentheses around it, plug it in, and then simplify. So 1 squared minus 1 is 0. That's pretty easy. F of root 2. In previous classes, you probably didn't plug in stuff like root 2, but we're going to get really comfortable doing that. So again, replace every x with it. Always put it in parentheses. That'll help you throughout the class. One of the main things that we look at here is notation and strengthening notation. So even though these are problems you can probably do in your head, we want to do them, write out all the steps for them. So root 2 squared is just going to be 2 minus 1 equals 1. So those are really simple evaluate problems. So for one that's a little bit more advanced, you could have something like f of x equals negative x squared plus 2x plus 1. And we want to evaluate at f of a plus 1. Okay, so instead of plugging in a number, we're going to plug in an expression a plus 1. So we replace x with a plus 1. And every time we do that, we're going to put parentheses around it. So I'm going to have this negative sign out front, and then I'm going to replace x with a plus 1 in every place. Okay, and that's really the jump, where we need to be able to plug in expressions, anything into x. So once you do that, it's just a simplification problem like you've done before. So a plus 1 squared is a plus 1 times a plus 1. So that would be a squared plus 2a plus 1. And then I'm going to simplify the 2 times a plus 1. So distribute the 2. I get that. And then the next step is just to keep simplifying until you can't anymore. So I'm going to distribute the negative sign. And then cancel what cancels. So the 2a's would go away. Negative 1 and 1 goes away. So we would just be left with negative a squared plus 2. Okay, so that would be evaluating at a function, so a plus 1. Okay, so another type of evaluation would be to evaluate a piecewise function. Piecewise functions are what they sound like, so they're a function in pieces. So the function will spit out 37 if x is greater than or equal to 0, and 40 minus x squared if x is less than 0. Okay, these are called domains. So we have first a domain of x is greater than or equal to 0, and the second one is x is less than 0. So whatever value that you are asked to evaluate at, you're going to plug it in to that part of the function. So if you had to find f of 0, okay. Well, f of 0, where does 0 fall? So does it fall into this domain or does it fall into that one? Well, x is 0, right? That's the number we're plugging in, so it's going to fall into the top domain. So if if x is greater than or equal to 0, we'll get a 37 out. So this will just be 37. And there's no calculation to do. We plugged it into the correct domain and it spits out this number. Okay. If we have to find f of -2, okay. Again, check the domain. So -2 is definitely less than 0. So we're going to use the second domain. So we're going to plug it into that part of the function, which is 40 minus x, back up, 40 minus -2 squared. And then we simplify that. So it would be 40 minus -2 squared, or 36. Okay, so the last little topic today, this is a pretty short set of notes. We're going to look at the difference quotient. So the difference quotient is something that comes up in calculus. That's the primary place for it. And it is this expression. It's f of x plus h minus f of x. So I'm going to do this in parts just to show what's happening. But you can do this all in one step. So if a problem says find the difference quotient, abbreviated to DQ, for, let's choose a problem like f of x equals x plus 1. Okay, basically you just need to find each of these parts. So if I, f of x plus h means replacing x with x plus h. So I'm going to plug in, this is like the one we did where we plugged in a plus 1, I'm going to plug in x plus h. Okay, well, what that's going to make me do is this. Anywhere there's an x in here, which is right here, I'm going to plug in an x plus h. So this would be x plus h, and then I have to add this 1. So this would be 1. Okay, so that is f of x plus h. And then the next part in the function, this tells us to find f of x. Well, that's just given to us. So f of x is simply x plus 1. Okay, so the next part would be to put these all together. So if I take that equation, I'm actually going to just copy it down here. Okay, I'm writing it there so you can see that it's parallel. So f of x plus h is x plus h plus 1 minus, and f of x is just x plus 1, but you have to put it in parentheses. And that's all over h. So in all of these problems, the h will cancel out no matter what. It'll always cancel out. So if your h doesn't cancel, then you probably have some mistake in there. But you just simplify this. So x plus h plus 1 minus x minus 1, if I distribute that sign. And stuff cancels. So the x's cancel, and the 1's cancel, and I'm left with just h over h, which is simply 1. So the difference quotient for f of x equals x plus 1 is equal to 1. So that result we're going to talk about a lot more later, but right now we're just looking at the mechanics of plugging in things to the difference quotient. So if you have any questions, please make sure to visit me during office hours or send me an email and I'll get back to you. Thanks.